before that problem. Says P of x is a polynomial. Suppose that the coefficients are in real numbers, okay? And a
Okay.
is a real number, is constant. And P of x and a is not zero. P of x is equal to P of x plus a for all x's in real numbers, okay? For all x's in real numbers, we have this equation. Then it says find all P of x. Okay? Understood the problem is what?
So px is a function. Px equals
Yeah,
px
no,
plus
it's
a.
not function. It's a polynomial. And when we write these, it means that the coefficients are real. Means in general, when you want to, for example, px is what? We can say if the degree is n, px is an xn plus an minus 1 xn minus 1 plus a1x plus a0 and ai's are real numbers. Okay? And then it says we have a constant a that p of x for all x in real numbers is equal to p of x plus a. It says find all p of x. Okay? So try solve this one. And I told you, I think, functions, and we solved some IMO problems in functions, right?
Mm-hmm.
Okay. Now you should work on polynomials, right?
Is it a horizontal line?
Horizontal line? Yes, means constant. P of x should be constant, right?
Mm-hmm.
Agree?
Yeah.
Okay, how have you proved this one?
Well, I can't figure out like a rigorous proof, but first of all, p0 equals pa, p negative a equals p0, and basically you get like p0 equals pa equals p2a equals p3a equals, and
Look,
there would just be,
P0 is equal to A0, right?
yeah,
Then it is equal to P of A.
yeah, just equal to p of negative a equal to p of 2a.
You know it is
P of,
equal to also P of negative A.
yeah.
It is equal to all these things. Then what?
Well, it's also equal to p of 2a, and
Yes, P of 2A, P of 3A, then what?
well, so it has like infinite numbers that are the
You can say,
same.
for example, if A is positive, if you increase this, it approaches infinity. So, for example, it approaches infinity or positive infinity or negative infinity, and it is not A0, right?
Yeah.
But it's better to reach a rigorous proof. Let me tell you in polynomials what thing is important. Well, here we know P of x is P of x plus a. Okay.
Mm-hmm.
Then we agree a and x and we can write this one again. This one is P of x, right?
Yeah.
And we agree is equal to a n x plus a to the n plus a n minus 1 x plus a to the
Yeah.
n minus 1 plus
Yeah.
a1 x plus a0.
Yes.
Okay, and the agree it is correct for infinitely many x, right? So when
Yeah.
these two are equal for infinitely many x, what can we conclude?
Um. X to the or an. Well, all the an is equal to an.
Corresponding coefficients should be equal, right?
Yeah, corresponding
Because look,
coefficients equal.
when, for example, you say, okay, minus this is equal to 0, it is a polynomial, right?
Yeah.
and we know it has infinitely many roots, right? For all x's, it is 0, right?
Yes.
If it is a polynomial, it has, for example, if the degree is k, it has at most k roots, right? K real roots.
Yeah.
When we have more than that, more than k roots, then all coefficients should be 0, right?
Yes.
Okay, and here, because it is correct for infinitely many roots, so all coefficients should be 0. Means what? It means that if you consider equation, all corresponding coefficients are 0. For example, coefficient of xn on the left-hand side is what?
0.
No, not 0.
Oh, you mean an?
Yes, and what about the right-hand side?
An?
So we've not reached any important thing. And here, when we consider this polynomial, degree is n. So we can say an is what? An is not 0, because if an is 0, the degree is not n. Start from here, right?
Yeah.
So we can say we have two cases. Case 2, we have a polynomial an is not 0. Otherwise, we can consider p of x if it doesn't satisfy this. Then we can consider p of x is what in the case 1?
P of x is an minus 1 times n minus 1?
No. Look, here I consider leading coefficient is not 0, right?
Yeah.
If leading coefficient is not 0, always we can say leading coefficient is not 0. Otherwise, it means that p of x is what?
So that means P of x is equal to a
0.
0.
0.
0.
Because look, if you have at least one non-zero coefficient, so that will be the greatest one will be leading coefficient and it's not 0. If you cannot find any coefficient like this, it means that p of x is 0. So for example, suppose p of x is 3x squared plus 5x plus 10. So 3 and 3 is not 0. P of x is, for example, 2. So 2 constant, the degree is 0, and leading coefficient is not 0. But when you can't write like this, it means that all coefficients are 0, right?
Yeah.
Okay, in the case 1, it is correct. It satisfies the problem. P of x is equal to P of x plus a always. Or both of them are 0, right?
Yeah.
Now you can say an is not 0, and we know degree n is at least 0. Okay, so now consider other coefficients and you can reach some good results and you can find polynomials. Okay?
Okay. So there's a polynomial answer to the problem?
Yes. For example, you say, okay, our polynomial is 2x plus 5, something like this, for example. Okay?
Okay. Wait, wouldn't px equals other constants also work?
Yes, if p of x is constant, here, if you consider other coefficients, you will reach that only for constant works. Okay? Consider coefficient of other thing, then you can prove that. Okay?
Okay. So when I consider an minus 1, I get
You considered coefficient of x n minus 1.
yeah, xn minus 1.
Then on the left hand side, it would be what?
An minus 1.
What about right hand side?
An times n choose 1 times a
Yes,
plus an choose an minus 1.
exactly. Then what?
So now I get an times n minus or n choose 1 times a equals 0. So
Yes.
an is 0.
We said in this case, an is not 0, right?
Oh, but then what is 0? So it's a contradiction.
No, not contradiction. So we can conclude what?
A is 0?
A also by the assumption of the problem, we said it's not 0, right?
It's not 0.
So then what?
N choose 1 is 0?
N choose 1 is 0. So then what can we conclude?
How can n choose 1 be 0? And n is 0.
Any 0. Then what?
So it's just a constant term.
Exactly. P of x is a0, and we know P of x in this case is equal to P of x plus a. Both are equal to a0, right?
Yeah.
So we proved this problem, right?
Yeah.
Okay, so it should be a constant, and this one is a special case of that constant. It can be 0, so
Yeah.
P of x should be constant. We proved, right?
Yeah.
Okay, it is the most useful approach for proving polynomials that, for example, equations in polynomials, like functional equations that we had some, for example, tips, techniques to prove in polynomial, considering corresponding coefficient is so much useful.